Hey, 7th grade, here is our 4th lesson in chapter 0. This is about comparing and ordering rational numbers. This is a little bit of a long lesson, so I'm going to try and go quickly, but there are a lot of slides, so I do know this might take a little longer than normal. Just prepare yourself. Okay, so let's start off with definitions. First, the definition of a rational number is any number that can be written in fraction form. So rational numbers, you've seen them a lot. You've dealt with a lot of them. In fact, you probably can't really think of an example of a number that is not rational off the top of your head, but I'll show you some of those in a minute. So, examples of rational numbers are obviously fractions, like 1/2 or 3/4. You could write down any fraction you can think of there. Mixed numbers, well, that's the same thing, but with a whole number piece as well. So maybe 3 2/3. Or 5 1/9. Those are both mixed numbers. They can both be turned into rational numbers. Whole numbers. Well, we know that a whole number can be turned into a fraction as well. So the number 5, the number 7, the number 213, all rational numbers. Terminating decimals. Okay, so you maybe are not familiar with this word terminating. Terminate means to end or to stop. So a terminating decimal is a decimal that stops, like 5/10 or 215 thousandths or 8 75/100ths. All of those are terminating decimals because they end. Well, the other type of decimal that you're probably thinking about now is repeating decimals. Repeating decimals are also rational. They can be turned into fractions, and I will show you that in another video. But a repeating decimal might be like 0.3 repeating, so maybe we'll write it with the repeater bar, or maybe we'll write it like this, 0.67 with the repeating section shown and an ellipse at the end. Maybe we'll even write one like this, 0.555 ... Okay, so all those are repeating decimals as well. And there's one more type of number that is a rational number, and that's a percent, like 92%. We can turn that into a fraction if we want. Okay, or 115%. So all of those numbers are rational numbers because they can be written in fraction form. So like I said, you're probably wondering, well, if these are all rational numbers, I can't think of a number that's not rational. And yeah, you can. I'll show you. So an irrational number is a number that cannot be written in fraction form. A number that cannot be written in fraction form. And there are some examples that I have for you. The first example is a decimal that does not terminate and does not repeat. So a decimal that does not end and does not have a repeating pattern. So I can just make one up. How about 8.13125689 ... So the ... at the end, the ellipsis at the end, tells us that we are going to continue. The fact that there's no pattern going on here and the decimal piece tells me it doesn't repeat. So this would be a non-terminating, non-repeating decimal. And that, my friends, is what an irrational number is. But that's not it. That's not the only one. Let me show you another example. This one's a little higher level math. We'll deal with this one a little bit later in the year. But if we try to take the square root of a number that is not a perfect square, so for example, the square root of 2 or the square root of 8, those numbers do not have perfect square roots. They're not a perfect square number. So the result would be one of these non-terminating, non-repeating decimals. If you want to pause the video and you want to go to your calculator and check these in the calculator, you can do so. You're going to see you get a decimal for each of them that does not end and does not repeat. You may think that's all, but it's not. We've got another type of irrational number coming at you, and there are some famous ones. Famous irrational numbers, which again are non-terminating, non-repeating decimals, like, I bet you've heard of this guy before, pi. Okay, pi is the ratio of a circle's circumference to its diameter. It is a non-terminating, non-repeating decimal that we tend to estimate as 3.14, but it keeps going on and on and on and on and on after that 4. Another famous irrational number is the number e, which is called the Euler number. That's a number that you'll learn about a little bit more in high school and more advanced math. But if you do a little Googling on what the number e is, it is a non-terminating, non-repeating decimal. So it is irrational. Great. So let's move on. So to compare different types of rational numbers, so pretty much we're talking about these rational numbers, these decimals, fractions, percents. To compare these types of numbers, we first have to change them to the same form, meaning we want to change them all to fractions or all to decimals or all to percents. And the most common choice is to change them all to decimals. And the reason for that is the decimal is like a middleman. It's very easy to turn a fraction into a decimal. It's very easy to turn a percent into a decimal. It's a little more complicated sometimes to talk between fractions and percents. Okay, sometimes it's very, very easy, sometimes it's more complex. So the system we usually use is to turn all the numbers into decimal form, and we can compare them that way. That's if we have a mixed list of rational numbers. So how do we do that? How do we change? Let's start off by talking about how do we change a fraction to a decimal? Well, the only step you really need to know is to do some division. You're going to divide the numerator by the denominator. So if I start off with a fraction like this, n means numerator, d means denominator, the numerator goes inside the division house and the denominator stays outside. That gets mixed up by a lot of students because typically our denominator is the bigger number and they want to put the bigger number on the inside of the house. But no, don't do that. Numerator inside, denominator outside. We're going to see an example. Let's check it out. So we want to change 5/8 to a decimal. Here's what I like to do. This way I always get the numbers in the correct place in the division box or division house. I write my fraction, then I draw my division sign right on the denominator, and I bring that 5, that numerator, into that house. Now, if I want to do some division here, I cannot take 8 and put it into 5. So I've got to add a decimal. I've got to add a 0. And now 8 goes into 50 just fine. 8 goes into 50 6 times. 6 times 8 is 48. And when I subtract, I get a 2. Bring down another 0. 8 goes into 20 twice. 8 goes into 20 twice. 2 times 8 is 16. And when I subtract, I get a 4. Bring down one more 0. 8 goes into 40 5 times. 8 times 5 is 40. And I'm finished. So 5/8 as a decimal is 625 thousandths. Okay? Pretty easy. Just keep dividing until you use all of those zeros. All right. Now, the next example I have for you, it looks like it's going to be a whole nother problem, but it really isn't. Here I've got a new example. It says, well, now let's change 5 5/8 to a decimal. Well, don't let this become a hard problem for you. Okay? Here's the trick. 5 is the whole number. So 5 comes before the decimal. Now we already know that 5/8 is equal to 625 thousandths, so that comes after the decimal. A lot of students make this problem way too complicated. A lot of students try to change this to improper and then divide. Oh my goodness, guys, what an extra step. Unnecessary. The whole number is the whole number, whether it's in fraction form or decimal form. So let this be your quick lesson. Make these problems very nice and easy. Take that whole number, drop it into the whole number place, and then just do the division to figure out your decimal. Okay, let's keep moving. To change a decimal to a fraction, this is really, really easy. We call these the 3 R's. We read it, we write it, and we reduce it. Now, I know write starts with a W, but you get what I'm trying to say here. Read it, write it, reduce it. We read the decimal in correct decimal place form. We write what we hear, and then we reduce the fraction or simplify. Okay, let's see an example of that. Really quick review of place value. This is under the read it section. Remember, you've got your decimal point here. All the numbers to the left are whole numbers. All the numbers to the right are decimal place values like tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions, and it keeps on going. So if you need to use this chart, you can reference this at any time to kind of help you read those numbers. Okay? We read by the smallest place value. So let's do 1. Let's see what it looks like. So we're going to change this decimal, 0.775, I know that's not how we read them. We're going to change 0.775 to fraction form. Well, I'm going to read that according to my place value chart. Here's my decimal, 775. My phone's ringing and I'm not answering it because you guys are way too important. Okay, so cover the decimal for a second, ignore it. This number will be read as 775. The 5 is in the thousandths place, so it's 775 thousandths. 775 thousandths. So I read it, I write what I hear, 775 thousandths, and now I reduce or simplify. So I can divide both of these numbers, believe it or not, by 25. You could do this by 5 and then by 5 again. They both are divisible by 25, so that's 31/40ths. 31/40ths. Okay, so one more thing. If I want to do the same thing with the whole number piece, remember, don't psych yourself out just because there's a whole number there. That 8 becomes the whole number part of our mixed number, and that 31/40ths just gets transferred into our fraction piece. Okay? So this is a good place for me to stop this video. This is video number 1 of 2. I don't want it to get too long. I will do video number 2 in just a moment, and then you'll have 2 shorter videos so as not to be overwhelmed by a long one. Okay? Take a break, review what we talked about so far before you watch the next video.